G'day guys, welcome back. In this video we're going to cover polymorphism, the last of the 4 object-oriented principles. In the last video we covered abstraction. Just in case you haven't seen that video, I'm going to put a link to it in the description. In this video we're focusing on polymorphism. And this is going to be a short one because we already actually have a perfectly good example of when this can be used. So in the last video I was really feeling the pain of having to copy this, and you also saw me struggle with a little bug that got introduced where because I had copied this, I'd forgotten to update this from Mario to Luigi down here where I copied it. And this is one of the problems with copy-paste programming. And if you can, there's it's really better to try to get your code to be reusable and generic and flexible such that you don't have to copy it. You can just reuse the code that's there. And that's basically what polymorphism is about. So polymorphism is about writing code that is able to be reused, though it may behave slightly differently depending on the class that it's being used upon. So that might sound a little confusing. So let's just get straight into our example. What I want is I want a function that will log out a player's current speed and their current x coordinate, then move the player and then write the new x coordinate. So I'm going to create a function here and I'm going to call it void move player and print. This is probably a horrible name, but you get the idea. We want to move a player and print their information, something like that. Now, let's just start with again a bit of a copy, right? For starters, if I use Mario here, it can only really let's firstly abstract this out. So if I use a parameter, use an argument instead of using this guy up here, or even to make this even safer, we could do something like void main. Let's create a main function. All this stuff goes inside main. And down here we'll just call main. So that way we're not able to accidentally access Mario from in here. So if we pass in Mario as a parameter to this function, we can, it will compile and it will run, but it's coupled. It will only work with Mario, whereas what we want is we want to use this polymorphism thing so that this code that we've got here will work with any player. So if we come back to the definition, the secret is kind of in this player base. This is the parent. This is the common stuff. And so long as we're only accessing common stuff, like if we had, void do Mario thing, right? So long as we don't need this Mario specific function, right? So long as we're only really working with this common stuff here, we can actually use the common class, the base class. So instead of passing in Mario, let's pass in the base class. Let's rename this from Mario to player, and let's change this from, instead of Mario, I'm gonna do a little C# magic. And I'm going to say player.getType, which will basically give me the type of the child class. So if it's Mario, it should give me Mario. If it's Luigi, it should give me Luigi, and it will match basically the name of the class here. And we'll do the same thing here. Whoops. There we go. There we go. And in fact, we don't really need this guy down here because, as we saw, after you move You know what? I might actually remove it from here and add it back because this way it will at least tell us the type. So I think that looks pretty good. Let's just add the curly brackets here so the string interpolation works. All right, yep. And now what we can do is we can say move player and print info for Mario. And we can use the same thing for Luigi. Move player and print info Luigi. And you could say that this function is polymorphic because it will behave, well, more or less the same, but it can be reused regardless of what child class is passed into this. Yeah, regardless as to what child class is passed into this, it can still be used, and the behavior will actually be slightly different because in our implementation we've abstracted out the speed. So Mario will move still slightly quicker than Luigi. In practice, these sorts of things can have more drastic differences. So there could be a difference between writing to a database and not writing to a database, depending on the implementation, of the derived class or the child class. In our situation, both of them are pretty similar. But let's go ahead and run this and see what we get. Cool. So the name is actually giving us what we would call a fully qualified name. So you're getting the namespace. So this is kind of starting to touch on a C# concept, but you can just think of it as like nesting. Our main solution is called samples.oop, and stuff inside the solution has that prefix, is I think enough for now. So you've got Mario speed 30, his x is 50. After he moves, his new speed is 8. His new x is 80. Luigi has a speed of 20, starting x of 50. After he moves, his new x is 70. So we've now got a polymorphic function. And I think as a general principle, if you've got a class that inherits from something and you're writing a function that accepts an argument or that has a parameter of that class, you may want to consider making this polymorphic from the beginning. So instead of using Mario here, it's usually a better idea to actually accept the base class and have this work with whatever child class that you might introduce later, rather than having to do it retrospectively. So if we wrote this to work with Mario only to begin with, and then in 3 months' time, we all of a sudden had a dozen different player types, and then we had to rework this after the fact to work with all of the different types and make it polymorphic after the fact. It's often much more difficult than just making it polymorphic to begin with. So yeah, just a little tip. If you find yourself using a class as an argument and that class has a base, maybe it's worthwhile considering, is it a better idea to just accept the base here and have this polymorphic? So that's basically it. That wraps up our 4 OO concepts. There is still more to cover in the OO world, but these are the 4 basic principles. And if you're wondering what does OO code look like, hopefully this little coverage gave you some idea. If you'd like to see any more OO topics covered, since there are plenty more, or if you'd like to see a deeper coverage of C# or any other programming paradigms like functional programming and so on, feel free to leave a suggestion in the comments. Otherwise, thanks for watching, and I'll see you later. Bye.